Let's take a look at this last section of chapter 23, which is going to be breathing rate and homeostasis. So this is taking a look at the effects of hyperventilation and hypoventilation. So in this one, and I introduced this in a previous section, but we're going to take a little bit more into it here. So first, let's take a look at hyperventilation. So the definition of hyperventilation is going to be where you have an increase in your breathing rate or depth above the body's demand. There's a lot of different things that can cause hyperventilation. Anxiety will cause an increase in respiration. And also increasing your altitude will also cause an increase in hyperventilation. If you think about it, the reason why is because you are going up in higher altitude where the oxygen levels are going to be lower. Those partial pressure oxygen levels are lower. So your body is trying to get in as much oxygen as possible. Or it can be voluntary. Maybe you are forcefully hyperventilating, right? Maybe you're going in and you're competing for swimming. You want to hold your breath as long as possible, and you force yourself to hyperventilate. It happens. So I don't know how many swimmers do it, but I know that swimmers can do it. And I talked about the problems with this in a previous section about how if you go through and cause yourself to hyperventilate, you wash your blood of carbon dioxide, which is going to be the gas that triggers inhalation. So if you get rid of it, it's not going to trigger inhalation, right? So you're going to hold your breath for longer, but the problem is that your oxygen levels decrease, and then you are going to pass out in the water, which is never a good place to pass out, I would think. So that is going to be one of the problems with hyperventilating, forcefully or voluntarily hyperventilating. So what happens, how this affects your blood is exactly what I talked about. So you're basically washing your blood of carbon dioxide levels. So the partial pressure of oxygen levels actually go up in the alveoli. And so the additional oxygen actually does not enter the blood because of the fact that at 104 millimeters of mercury, your hemoglobin levels are already 98% saturated, and it can't be any more saturated than that. Remember, because 2% is going to be dissolved in plasma. So it's already at its capacity. What it affects is going to be carbon dioxide levels. Your carbon dioxide levels are going to go drastically low because of the fact that you are breathing, exhaling so fast and so much that you're washing your blood of carbon dioxide. So this term, this blood CO2 levels that decrease, these abnormally low blood CO2 levels, is called hypocapnia. So let's take a look at the effects of hyperventilation. So since you have low blood carbon dioxide levels, this causes vasoconstriction. And another thing is that you are also going to cause, since you have vasoconstriction, it is going to cause a decrease of oxygen to the brain. And of course, decrease of oxygen to the brain means that you're likely to faint or go unconscious because of it. And another thing is that it's going to decrease your hydrogen ion levels in the blood. And that, if you decrease hydrogen ion levels, remember that that is going to cause your blood to become alkaline. So it could result in something called respiratory alkalosis. The reason why it's called respiratory alkalosis is because it became alkaline from you hyperventilating, which is a respiratory effect. So some of the causes of hyperventilation, some of the hyperventilation, some of the symptoms that it can cause is fainting and dizziness, which is what I just talked about, that decrease of oxygen delivery. It can also cause numbness because, again, decrease of oxygen delivery, but it also can go in and cause problems with the nervous system. So that's where that tingling comes from, and also cramps, tetany. So if you remember tetanus or tetany from 2401, that's that sustained contraction. If it's prolonged, again, loss of consciousness, eventually a coma, and death can result. So again, I would highly recommend going and watching that TED talk with David Blaine that I posted online. It's very interesting if you have time, 17 to 18 minutes long. If, like I said, I don't believe in magic. I know that David Blaine's a magician, but this doesn't have anything to do with magic. It has him going in and breaking the world record of breath holding, and he talks about hyperventilation and his struggles to do it and everything like that. So it's a fascinating talk there. So now let's take a look at hypoventilation. So hypoventilation is going to be where you breathe too slow. Or you breathe too shallow. And there's a few different reasons why this might happen. Pneumonia can cause hypoventilation, airway obstructions, so something might be causing a blockage in the airway, a brainstem injury, because remember that you have to have a stimulus from that medullary group in order for you to go in and inhale and exhale. So if you have an injury, then that's definitely going to cause hypoventilation. So let's take a look and see the effects that it has on the blood. So it does two things. It decreases oxygen levels, and it's going to increase O2 levels. So this, whenever it goes in and increases CO2 levels, is called hypercapnia. The reason why it's going in and increasing CO2 levels is because you are not exhaling out enough. So the CO2 is actually going to go in and collect in your bloodstream. The PO2 levels are the partial pressure of oxygen is going to decrease, and this is going to be hypoxia here. So the problem that comes about with this is it's going to be, again, inadequate oxygen delivery. And the problem with this the CO2 is going to be, remember that is going to eventually lead to hydrogen ions, and then that is going to cause respiratory alkalosis. And we'll talk more about alkalosis later on in the fluid and electrolytes chapter. So with hypoventilation, some of the symptoms that it can cause is lethargy, sleepiness. Again, that has a lot to do with like your low PO2 levels, that hypoxia, headache as well. Polycythemia. This is going to be an increase of red blood cells. The reason why this happens is because your body senses that there's not enough oxygen levels. So your erythropoietin kicks in, and it is going to kick out more red blood cells because of it. And also cyanotic tissues. Again, you have a decrease in oxygen levels. If this continues, then it can lead to convulsions, again, and also loss of consciousness and eventually death. So now let's take a look and see what happens with breathing and exercise. So while you're exercising, one of the things that's stimulating it, and this is something that we talked about in an earlier section, is the body movement. It stimulates those proprioceptors. And what that does is it stimulates your breathing depth to increase. However, your breathing rate actually remains the same. So that breathing depth that increases is called hyperpnea. So your PO2 levels and your PCO2 levels usually are going to remain the same. However, what's happening here is it's going to go in and increase your cardiac output. The respiratory center is stimulated mainly because, again, of the movement that's happening from those the proprioceptors. Motor output from the cerebral cortex will also stimulate it. Remember we talked about how the higher brain functions or centers like the cerebral cortex, that specifically goes and skips the medullary respiratory groups, and it goes in and innervates directly those motor neurons that are affecting or that are going in and innervating the diaphragm and the muscles of respiration. So the cerebral cortex can also relay, this one says it relays it to the respiratory center, but the earlier sections talk about how it completely skips that step overall. So it's kind of contradictory here. And also just going through and anticipating your exercising, it can cause anxiousness maybe. If you're not really into exercising, then you become a little anxious. or you become excited about it. Either way, it will actually go in and stimulate your respiratory system because of it.